おはようございます。だいぶ時間が空いてしまいましたが、また作業配信やっていきたいと思います。ちょっと、仕事やら日常のことやらでちょっとバタバタ落ち着かない日が続いてたんですが、ようやくいろいろと一段落してきたので、またやっていきたいなと思ってます。で、なんかそうこうしてるうちに 19.5 とかが出ていて、なんかいくつか新しい機能とかノードとかも追加されてるみたいなので、今回はせっかくなので 19.5 を触りたいなと思ってます。で、今回はその中でもシャローソルバーだったかなという、なんかハイトフィールドからなんか浅瀬のなんか小川とかなんかそういうのを作れるようなノードが追加されたみたいなので、ちょっとそれを元にした作例をいつものように動画を見ながらやっていこうと思います。はい。なんで、バージョンは 19.5 です。
Just as I'm about to leave for SIGGRAPH, meet me there on August 9th and 10th, I thought about a neat new addition to Houdini's toolset in 19.5, which is the Shallow Water Solver, a very capable small solver that I think was originally intended to replace the Ripple solver, but can do so much more. I highly urge you to check out the example files in the documentation, but today I don't want to use a shallow water solver to simulate rain or a flooding canyon, but instead build this artwork of meandering abstract flow lines around our logo. And for that I prepared two files. One is this, it's just a PNG that is black and white with this slightly blurred Entagma N in the middle and a sharp circle around it. And the other one is this, just the same sharp circle divided into 4 segments. And we're going to use these 4 segments to emit water into our scene, and this Entagma N here as a height field around which the water should flow. And then we're going to visualize the velocity field that the flowing water has. To build this in Houdini, the first thing what I want
はい。というわけで、Houdiniに切り替えていきます。バージョンは 19.5 です。で、一応、ビルド2というデスクトップを作って、多少作業しやすいようにカスタマイズしてます。
to do is over the viewport, hit D for display, and then go to background and set this to dark so we can see a bit better. Then I just want to look down on this ground plane here.
やべえな。久々で手が動かねえな。ダーク。シフト。パラメーターがない。
And in our OBJ network here, let's hit tab, type geo, drop down a geo node, dive in there. In here, the first thing I want to do is load up these files, which I've shown you, and use them as height fields and as a mask, or rather a source region.
俺ジオメトリー、いつの間にか中に入ってた。視点ってどうやって切り替えんだっけ？いいか。
from which to emit water. So the first thing I want to do is drop down a height field from file, height field file node here, and in here I will point this file here. Here by clicking here and then navigate. To where I stored these PNGs I prepared, and you can see
タグマの動画はだいたいプロジェクトファイルがダウンロードできるようになっているので
scroll down again and select the correct.
こんな感じですね。この URL からプロジェクトを落とせるので
File here. That's this one. I can check that here, and now I can scroll down again and select the correct file here. This one. And now I want to drag this down and check the grid spacing size. And then just decrease the grid spacing to 0.01 and zoom out a bit here. So now I've got this here. This is my height field. So this N. With a circle around it. Next, let's add the source. That's the other image I've shown you by copying and pasting this height field file here and wiring it up below here. And automatically Houdini has copying and pasting the height field file here and wiring it up. That's the other image I've shown you by copying and pasting this height field file here and wiring it up below here. And automatically Houdini has set this here to create a new layer called mask. Now let's just exchange that file here for the other one we prepared. By again loading it up through the file load dialog, and it's that one here, and you can see those areas are now masked, and later we will use those for emitting water into the scene. However, the first thing I want to do is add a bit of noise to our source here, so to break up these sources here, make them a bit more organic, but also to our underlying height field to make the flow of water a bit more organic. I can do that using the height field noise, HF noise, adding that down here, and then let's set the amplitude to only 1 and decrease the element size to make the noise a bit smaller, like so. That is looking fine. Let's add another height field noise. Attach that. And now let's noise the mask. Let's add another height field noise. Attach that. And now let's noise the mask layer, the one where we emit the water.
じゃあ勝手にハイドレイヤーとしてセットされてるってことなのか。
Water from later. And here as well, let's dial back the amplitude to maybe 5, and also let's decrease the element size quite drastically to 0.25. And then let's set the combine method not to add, but to multiply. So now I'm multiplying in this noise here into those areas which emit some water later. But also I want this noise to be animated. So in this case I will animate just the Y offset, which you could either do by manually keyframing this or using a small expression, which I will do, just typing in $FF times 0.01. That means take our current frame and multiply it with this constant here to slightly animate this over time. And if I click here, I can see the actual value that's set in here. And if I play now, you should be able to see the slowly undulating noise here in this areas where we're going to emit water into the scene here. All right, that's fine for now. I think we're already so far that we can use the shallow water solver to set this up. So below the second height field noise, let's drop down the shallow water solver. Here it is. And that just has this one single input here. Let's highlight it. In here we have to set up a few things. So let's just drag this parameters down here and let's maybe start at the bottom here. So first I want to dial in speed limits. Those make sure that our simulation stays reasonable and we don't get excessive wave heights or speeds in our simulation that could mess up our simulation and lead to very implausible and sometimes even broken results. In my case, through a bit of experimentation, I found a wave speed of 2 and a surface speed of 4 sufficient here. But also I want this sourcing to happen each frame here because we're animating the source noise here, the red noise. So I want to check additive sourcing, then dial back the scale a bit so we don't emit too much water into the simulation. And then I want to set the source frequency to once per frame, so it updates. All right, let's get up here and check the simulation parameters frequency to once per frame, so it updates. Water into the simulation, and then I want to set the source frequency to once per frame, so it updates. All right, let's get up here and check the simulation parameters here. So under the simulation parameters, for this kind of simulation, I found increasing the substep to 20 helpful, because otherwise the simulation would show some artifacts, and also increasing the cache memory. I've got a bit of RAM here, so let's set this to 35 gigabytes. Let's check the output tab here, and let's set the visualization to color by water layer, and set the visualization range to be between 0 and 0.1, like this. And finally, under the bindings is where we set up which fields in our height field are used to emit water or to even sink water, that means to remove water from the simulation. And in this case, the source layer here, I want to set to mask again, and you can see now these red areas here have changed to the water we are visualizing. Now if I move this up here, maybe save this and hit play on the simulation, this takes a bit, but you can see there's water being emitted from those areas into the geometry we've created with that high field. Now, that already looks kind of interesting. To me, the even more interesting part is visualizing the underlying velocities using particle trails. And for that we can use the volume trail node, which takes a volume through which it trails a bunch of points to form those streamer lines we've seen in the preview artwork. Just to generate those points, I want to use a few tricks. Basically, I want to just have a grid with the same dimensions in X and Z as this height field here. So in my case, I could either manually create that or use a bound node to create first the bounding box around that field here, which now has an issue. Because I only want the lowest primitive here as our face onto which we will scatter a few points, and that is the primitive with the number 4. So in this case what I'll do is just attach a blast node, and in that blast node set it to primitives and blast everything but number 4 by just typing 4 in the group field and then checking delete non-selected, and now we are left with only the bottom face here. And now I can use a scatter node to scatter a bunch of points here. In my case I went with 30,000, like this, 30,000 points, and I went with 30,000, like this, 30,000 points, and increase the relax iterations a bit to 64 to make the spacing a bit more uniform. And that goes into the volume trail here, like that. Highlight that one here, and after a bit of thinking and maybe unchecking the primitive number display, you can see we're getting, well, let's call it interesting results. To fix these results, let's check here and select the velocity volumes here and select vel dot asterisk. And now we are selecting the right field that we want to visualize. In here, what I did is decreasing the trail length a tiny bit.
ベロシティがこうね。なんだ。関係ない。あ、分かった分かった。違うか。シミュレーションしてないからか。これは別にあれか。シミュレーションしなくても出るか。そりゃそうか。
And increase the CFL. The CFL is basically the point spacing in those streamer lines. And now if I check increase the right field, the velocity volumes here and select vel dot asterisk. And now we are selecting the right field that we want to visualize. In here, what I did is decreasing the trail length a tiny bit and increase the CFL. The CFL is basically the point spacing in those streamer lines. And now if I check the point visualization, you can see we have a very dense point spacing here. So if I increase the CFL to 1, you can see it gets a bit sparse. Also, down here, what I did is instead of using the infrared standard ramp here, dialed in a custom color ramp, which I can do by going to custom ramp here. And then I have a few points here with color down here. Made sure the interpolation here was set to B-spline to make the interpolation of the colors a bit smoother. And then I did something think like this and added 3 more points. And then I started out with, I think, a greenish color, like something in, I don't know, here, something like this. Then that goes into some orange yellow thing, so maybe something like this. Goes further into a more reddish color, or maybe a bit more orangey like this. All right, and then that goes into a blue, maybe not. Not as bright, something like this maybe. And then into a bright gray or white almost. Yeah, and that's the color palette I stuck with. And that's the really easy setup. Let's quickly talk about rendering. So for rendering this using Solaris and Karma, preferably Karma XPU, which doesn't necessarily need a GPU but also runs on your standard processor, let's create a few attributes. In this case, just a width attribute specifying how thick those lines. How thick those lines. Should be rendered later. So let's use an attribute create. Call the attribute we want to create width. And let's scroll down here and set its value to 0.004. Again, try. Well, an error when I set this up. Worked really neat for me. Alright, let's attach a null. Call this one out in all caps. And let's talk about rendering. As for rendering and Tagma style, by now you should know me, I'm lazy, so let's quickly talk about that. I'll switch to the Solaris desktop here, and in my stage where I assemble the scene for rendering here. The first thing I need to do is import the geometry in here, which I can do using the sub import node, which I will point to my out. Node under the geo1 here. Let's hit accept, and we are bringing in this geo here. Let's frame this a bit, and maybe let's progress in our simulation a few. first click here and wait until the sim runs to frame 144. Alright, next, just for later, I'll attach a material library where we'll set up and assign materials, then a dome light for using an HDR for lighting, finally my camera, which I will set by just control clicking on the camera.
ライト。作るとつながんねえのか。そっか。これ立ってないからか。シミュレーション進めた方がいいんじゃねえか、これ。
icon, which will immediately create the camera at the position where my viewport was at and automatically link it to the viewport, so I can just center and move my camera in the viewport itself here. Then for setting up the rendering and saving it out, let's use a comma render settings.
なんだこれは。なんでこんな動くんだ。厄介やな。なんでこれこんな動くんだ。意味わかんねえな。なんで。
And finally, a USD render op for saving this and starting the render. Support itself here. Then for setting up the rendering and saving it out, let's use a comma render settings. And finally, setting up the rendering and saving it out, let's use a comma render settings. And finally, a USD render op. For saving this and starting the render. And that is our tree for now. One more thing, for the backdrop, I would like to use a grid, so let's just type in grid here, which will automatically create a subgrade node in which we'll set up a grid just as a background here. And then to this as well, let's add a material library to add materials to it, and then maybe a transform to move it around the scene like this. So let's merge this with our streamlines geometry here, moving this up a bit and using a merge node between the material library 1 and the dome light, into which I'll wire this. Transform as well, and then on the transform, let's increase this backdrop scale to maybe 5 and just move it down a bit like so. And in here, for this to properly work, in the transform, what I want to do up here for the primitives, I either want to select all geometry primitives or just use them asterisk in. Sometimes quicker for my taste. Let's start by creating the background material, just a really simple one in here. And in this case, I want to search for subnet because I want to use a karma material. A simple one in here, and in this case I want to search for subnet because I want to use a karma material like subnet in here, which is just a container in which I can build my shaders. In here I want to disconnect the material X surface here, and actually I don't need that one here. I also don't need the inputs here. All I need is a standard shader, so I need that one here. I also don't need the inputs here. All I need is a standard shader. So in here, in this context here, in the common material X subnet, we have the really nice feature of only material X nodes being displayed in here. So let's use a standard surface here, and then
T か。TL か。スタンダード。これはマテリアル X。スペースメント。そう結構。
wire the surface out into this global surface output here. All right, on the standard surface, I want to dial in a really, really dark gray, so a brightness value of 0.02 like this, and then increase the diffuse roughness.
バリューだけセットでよかった。
A bit to 0.5 maybe, and dial back on the specular to 0, so no reflection. There, and that's it. And to make sure Houdini can properly pattern match the individual materials in here, let's call this one capital BG for back. Right, Back to our stage, back onto our material library here. And down here, I want to check assign to geometry and then select all geometry primitives like this. And now we've got a black backdrop. Just to get rid of this icon here for the light and for the background grid, let's just uncheck the background grid and scroll down here and uncheck the light icon. Right, let's create the material for our streamlines here by going into this material. Material library 1 here, and in here the first thing again is a Karma Material X subnet into which I will dive in, and again in here the inputs and the Material X surface can go, and I'm going to use a standard surface again to set up this material here. Let's wire in the out to the global output, and in here I want to go for a more metal-like look. So under the specular, let's decrease roughness, so we really have like shiny reflective metal. And under the base here, let's increase the metalness, in my case to 0.8, again trial and error when preparing the setup here. And now let's load up the color of those streamlines and use them for shading. And in the last tutorial I claimed that that could only be done through the primvar reader, which was not available in the Material X subnet here. But luckily we received a message that this wasn't true, and indeed in Material X we can use the geometry property value, this one here, to look up attributes from the geometry. In this case, let's just look at what we've got here. We've got this curve. Let's go back to our stage here. Here, and then we can see which attributes and which names these attributes have. That come with this geometry here. And we can see that some of our attribute names don't have changed. However, the CD, Houdini's lingo for color diffuse, has been automatically renamed to display color, in a similar fashion that UV would be renamed to ST. So that's one thing. Keep in mind when working in Solaris here. So let's go back into the material library and into the subnet, and let's dial in Material X's geometry property values here by setting the signature here to color. We want to look up a color that is called display color with a capital C like this. And then let's wire that into the base color. And that is all we want to do in here. The last thing we have to do on the stage context here is assign this material by again checking assign to geometry here. The last thing we have to do on the stage context here is assign this material in base color. And so all we want to do in here. The last thing we have to do on the stage context here is assign this material by again checking assign to geometry and Last thing we have to do on the stage context here is assign this material by again checking assign to geometry, and then down here setting this to all geometry primitives like this. Alright, finally switch to Karma up here, switch the viewport to Karma, and after a bit of thinking, we can see now getting this nice rendering. Let's maybe uncheck our or unlock our camera from the viewport like this. Then zoom in to see what we have here. And one thing that we're missing is the dome. Our camera from the viewport like this, and then zoom in to see what we have. Here. And one thing that we're missing is the dome light here to give a bit of reflection. So in here, under the base properties, under the texture, I'm going to load in one of my favorite HDRs from just this dropdown as I selected it previously. It's called Artist Workshop 4K. And now after a bit I think you can now see we are getting a few nice reflections from this backdrop. Now, one more thing I want to do is increase the intensity to 5.5. That worked really nice. Look through my camera again, and only rotate that dome light in the transform tab up here, rotate it by 330 degrees around X, and then around 90 degrees Z, and also let's set the transform order to rotation Z, Y, and X like this. And that's how I would like to have this rendered and have converged. And that's looking nice, so the only thing I'll have to do is, in my Karma render settings, set up my output picture. That's usually how I do it, like this, so we are creating a subfolder, and then in the USD render op, let's set this to render a specific frame range or a frame range, and then click render to disk or render to mplay to save out this file sequence. And that's it, the quick and dirty way of rendering these streamlines in Karma and Solaris. Now, as I'm about to leave for SIGGRAPH, I'm hoping and looking forward to seeing some of you folks in person finally for the first time maybe. And if you want to support us or learn more about Houdini, you might want to consider becoming a patron of ours. And for everyone already supporting us, thanks so much. It's through your help that we can run and Tagma like we do, with a very special thank you going out to Important Looking Pirates, Jellyfish Pictures, The Mill, Electric Theater, Pixonic, Random42, Rodeo Effects, Side Effects, Lusion, and Rafik Anadol Studios, as well as StyleFrame. And with that, as always, it is cheers and goodbye.
あとは好きに書き出せばいいと。 ってどこにいるんだ？はい。一旦、これで一通りできましたと。まあ、ちょっと、シャローなんちゃらを、シャロー、なんだっけ、シャローウォーターソルバーは、パラメータの設定が多くて、ほとんど使い方がよくわかりませんでしたが、変だよな。どこにある？とりあえずハイトフィールドを作って、それに合わせたマスクを作って、シャローウォーターソルバーでソースにマスクを指定して、これが水の発生源になる、みたいなことなんだと思います。なんか回転の挙動がおかしいな。なんでこんなぶっ飛ぶんだ。大丈夫か。なんで、あとはハイトフィールドを生成する画像とかで、なんか、いろいろやってみたりするのも良い気がします。うん、あとは、ソラリスですかね。ステージ。ここで、ライティングもカメラもレンダリングも全部1個でセットアップができるという。カルマのレンダリング、レンダラー使って、これ XPU ってどうなんだろうな。使ったことないんだ。なんか結局、サンプリング数上げないと全然綺麗にならない上に、サンプリング数上げたら結局遅いみたいな感じだったような。 はい。というわけで、今日のところは、こんなとこですかね。はい。今後も、また定期的にやっていきたいと思っているんで、よろしくお願いします。はい、ご視聴ありがとうございました。